Hello and welcome to the second instalment of the Product Lifecycle series brought to you by the British Plastics Federation and the Plastics Consultancy Network. Before we start, a huge thank you to Dr. Robin Kent for putting these webinars together and all who have and will be presenting throughout the series. Today's webinar is called Testing for Biodegradation of Plastics and Packaging Materials and is being presented by Dr. Mike Kaludis. Mike received an honours degree in materials science at the University of Crete, followed by a PhD in polymer nanosurfaces at the University of Edinburgh. He has over 12 years experience in the research, testing and development of plastics and composites. Before we get started, as ever, if you've got any questions, do pop them into the questions bar in the control panel and we'll get to them at the end. So without further ado, over to you, Dr. Mike.
Well, thank you very much, Miami, for the introduction, and thank you and the BPF for hosting us this in such a difficult periods and times. Basically, I'm happy to be here today and talk to you about the biodegradable testing of materials. I know that this is becoming a hot topic in Europe and the rest of the world, and has been really a big area, and there is a lot of room for development and research and testing out there in the market. So I shall start my presentation by saying today we're going to touch a topic about from where to start. Okay, we have biomaterials, materials that are intended to compost, and where to start in terms of characterization, and how can we move from the development stage all the way down to labeling and certification. A few words about the company that I work for is Impact Solutions. In Impact, we are basically the polymer experts all the way down from reactor and down to recycling. We're founded in 2002 as a spin-out company from BP Chemicals, and we are based in Grangemouth in the UK. We are an ISO 17025 laboratory accredited by UCAS and the European notified body for automotive tanks. Our main growth is not only from clear testing of plastics and composites, but also comes from the research and development on various areas. We have a major exposure and expertise across the whole plastic industry, and our main strong point is that we start from the solution, from problems of the plastics industry, and then we provide solutions through either development from Europe funded or UK or local funded, or from private funding. Also, we work with, from big multinationals down to small SMEs. One of the latest investments and expansion we have at Impact was on the biotesting. We have received a lot of inquiries the last 18 months or so about biotesting, and we have spent more than £500,000 into expanding to this area. And we have also recruited a team of polymer scientists and chemists and engineers that are expert on bio, and soil scientists that can be able to help us on that. Okay, and why we invest in, why the focus on biodegradables the last 2 or 3 years is obviously, as you all know, plastics have made a huge impact in society, and they are still very useful materials because of their lightweight and ease of processing properties. However, the waste management and the life cycle analysis is currently a priority for the industry. And the end of life now of the plastics is becoming a major issue. And the problem is combined with that a lot of, the increased need for food, and also the increased disposable income around the world has also increased the use for plastics that are used for packaging and any other single-use applications. This is where the biodegradable materials are coming into place. How can these materials help to to stop or to slow down the increased need of single-use non-bioplastics? However, I mean, okay, we have the solution. One of the solutions is the use of bio-based materials. Okay, so this is how now we're gonna start presenting and talking about what types of bio-based materials used in packaging applications are out there, and how can we characterize them and move into the certification. So, types of biodegradables. I'm sure that most of you know about the different types of bio. We have we hear about biodegradables, oxo-degradables, compostables, biopolymers. We all know about the oxo-degradables. Now they are being condemned by the European Union. They're still used in Asia. We also have materials which are biopolymers, but not biodegradables, or biopolymers, but compostable but not biodegradable, and so on. So it's like, it's quite complicated, this market. That's why I'm just trying to put things in order. In this presentation, we'll focus on the biodegradable materials, which are intending to be composting as well. Okay, some biodegradable materials, the most popular is like PLA and PCL, PBS, PBA. All these materials that are based in polysaccharides. Some non-biodegradable materials are like polyethylene, let's say, for example, that you add additives in them to enhance the biodegradation. The ultimate, what do we mean by the word biodegradation? Okay, according to the literature, ultimate biodegradation is a breakdown of the substance to CO2, methane, biomass, H2O, or any other inorganic substances such as NH3. Mike's meaning of biodegradation, I have adopted the European Union definition, which is the conversion of carbon, of organic carbon, to CO2 by 90%. Okay, this is what I call a material biodegradable. We have different types of biodegradables, so that can be classed as commercial biodegradable. It depends on a number of factors, including the type of polymer, what type of additives do you add, the rate of biodegradation, the extent of biodegradation, and condition at the end of the life. These are important bits because you can call something biodegradable, but it will biodegrade with after, let's say, not in 20 years, but in 18 years. This is biodegradable. All materials in life are actually biodegradable, but some of them would just, the shelf life could be like half a century. Okay, so we need to start, when we speak about biodegradable materials, to put some dates down and some types of biodegradables. I mean, when are they likely to biodegrade, and also where, the location. And this is where now go to the location. So the end of life, the final destination of a material is very important. So when someone designs a material for being biodegradable, the first question I personally ask is, where do you intend to dispose your material? This is the first question, because when we move into testing and characterization and then subsequently certification of the material, we need to test it appropriately. There are different tests and methods for marine, different for sewage, for soil, landfill, anaerobic digestion, and composting, industrial composting. So that's the number one question we should answer. Where to start? When after we decided where do we intend to dispose our biomaterial, is that we need to see which route shall we follow for characterization and certification of the material. There are two major standards, European norms, and there are obviously the corresponding American ones, which I don't state them here. So we have for plastic packaging and films, we have the BSCN 13432, and for all the other plastics, we have the BSCN 14995. They're basically visually the same with small differences, and for this reason, I'm just going to focus the rest of the presentation on the BSCN 13432. It is a European Union standard, not an ISO, which just gives you a guideline from all the way from how to do the tests, how to choose the correct test, what do you call biodegradable, all the way down to certification and labeling. All right, so that's the title of the standard, which is packaging requirements for packaging recoverable through composting and biodegradation. It presents the test scheme and evaluation criteria for the final acceptance of packaging. This is majorly used for industrial composting testing of the biodegradable materials. And it gives strict guidelines, and especially when it comes to ecotoxic effects and toxic effects from in terms of heavy metals. That's very, very important. That's this area. So we start from the characterization. So we have the composting biodegradable material in our labs, and we've been asked to characterize it. Okay, that's the first step in order before we move to any long-term bio testing and certification. The characterization, then we have the biodegradability. After the characterization, we identify the different types of materials that the product is comprised of, and then we move into the biodegradability if required. Disintegration. Basically, on the biodegradability, we test the basic components. On the disintegration, we test the full product, and then the compost quality after the disintegration. And finally, we have the certification and the labeling. Let's start with the characterization stage. The first thing we do is infrared spectroscopy. We need to identify all the main components of this packaging material. We need to know all the additives, even down to 0.1%, before we do any test. The second step is we do a heavy metal analysis, not so much with XRF, but with ICP, because the limits specified on the PACN 13432 are so low. So we need to be accurate enough. So that's why we're using ICP method, inductive coupled plasma, coupled with optical emission spectroscopy. And as you can see, for example, on cadmium, the limit is 0.5 milligrams per kilogram. Okay, molybdenum, the same, it's 1 parts per million. So it's very strict there about the heavy metals. And yes, these are the two main tests: infrared spectroscopy, the ICP. After we do the FTIR and the heavy metals, then we need to decide what kind of test we're going to do on the biodegradability. We choose appropriate test standard. The BACN 13433 does not tell you what standard to use exactly. That depends, as I saw before on the presentation, the end of life. Is your standard water soluble? You can use a standard for that you use the medium for biodegradation of water. Is it for industrial composting? You use industrial mature compost for that. So that depends. And then obviously then just you place the material on test, and then you use methods to measure the gas as that being produced from the vessel, the plastic, the biodegradable plastic, and your medium. And obviously that will have different standards for anaerobic and different for aerobic. An example of aerobic standards is the ISO 14855. That's the patriarchy of standards, when you have to do the biodegradability testing. And as I'll remind you that the biotesting, that stage does not state the full material. It tests every single part of the final product. Okay, there are some products that are made of 3 or 4 materials, so we need to test them all 3 differently to assess the biodegradation of each individual component. The ISO 14855 is based on industrial compost, which is the main testing in Europe. It is popular in the UK as well, but then they mainly use it in Europe. So if your biodegradable material is intended to be used for composting, then it should be tested with ISO 14855, which basically we mix the biodegradable plastic with industrial compost, and we monitor the CO2 as is being produced from the reactors. For water and sludge and wastewater treatment works by degradation, we use the ISO 14851. That's mainly for water-soluble products. Or the ISO 14852. The difference between these two standards is the method you're using to measure the CO2. And obviously, we have the corresponding ASTM standards, which is the ASTM D5338. Then we move to the anaerobic tests. There are anaerobic tests, and it's for materials which you intend to use to dispose into anaerobic digestions. There are plenty of anaerobic facilities opening in the UK, has already been in full operation in the UK. The small problem I have with anaerobic is that they differ in temperature. There are plants which operate with solids and high temperature, plants which operate with liquids and high temperature, plants which operate with solids and low temperature, plants which operate with liquids and low temperature. So we need to watch that we use different standards intending to be used in different on each anaerobic digestion facility. So the ISO 14855, as I said, the main testing for biodegradability, it imitates an industrial composter, as I said, is maintained under conditions to simulate the condition of an industrial composter, and it works at 58 degrees, and you use a reference as a cellulose and then or a control as a blank compost. And as you can see on the graph, you can see the number one curve, which is the cellulose, and the two is the blank. So you have the blank, and then the difference between of the CO2 production of the blank and the cellulose is the biodegradation of the ultimate biodegradation you get. In order for the standard to be valid, you should get you should reach 70% of biodegradation of the cellulose after, I think, after 4 weeks or so. And yeah, so that's again the graph here. So it shows you how you present the results, how the production of the CO2 is being monitored in each vessel, and how you get the difference between the blank and the CO2, and the time in days as well. And usually the standard takes, you need to reach of 90% of conversion of carbon, of organic carbon to CO2 within 6 months. That's the result you get. And if you meet that criteria, your material is classed as biodegradable. Okay, then we move to the anaerobic digestion. The anaerobic is a closed system where you take all the air out, and then you just you take some material from the anaerobic digestion, you mix it with your plastic, and then you monitor the increase of CO2 and methane into the system. Not only you have CO2, but you have methane as well in the anaerobic digestion system. And then usually the test temperature is 52 degrees, but as I said, that compares to which anaerobic digestion plant you want to send your material to. The times are much less, like 2 months compared with the industrial composting. And then you just need, all you need to do is to monitor the methane and the CO2. And then you need to have a conversion of the organic carbon to methane and CO2 to 90% in order to class as biodegradable. And then if our material passes the long and the most difficult biodegradation stage, we move to the disintegration. This is basically the composting. Is my material actually composting? So we don't get the individual product, individual material, we get the full product. We cut down into small pieces as a full product, and then we placed it into pilot scale composters. So we mix food from food waste and leaves and garden waste, and then we mix all this waste with our material, and then we monitor within 12 weeks how the material is being disintegrated. The pass criteria, your material should pass through a 2 mm sieve after 12 weeks of testing. It's quite difficult as well, but yes, it is a test which is one of the main ones to pass. Again, if you want to do it for home composting, you need to make sure you do it at room temperature. The typical temperature for that is at 58 degrees, between 58 and 65 degrees. And then finally, after the last step of testing is the compost quality. So we take the compost from the disintegration, after we finish the test, and we take some of this compost with the plastic and the bioplastic in it, which is supposedly it has been biodegraded into less than 2 millimeter particles, and we plant trees, high trees in it, and using some lab scale LED panels, and then we just do testing of how we monitor how the plant grows. That's not, we just want to monitor how the growth goes for like 3 or 4 weeks. We don't wait for any longer. And the test is outlined on the OECD 208. It is quite well-known test for checking the soil and compost quality in the environmental sector. Obviously, additional heavy metal testing is required. For example, when testing in water, we do analysis on this analysis on cobalt as well after the disintegration testing. And when this also passed, there is no problem with high trees. We go to labeling. How do we present? How do we promote? How do we market? How do we recognize the materials? I personally, being a manager into the bio side, I had enough having, telling me that my material is biodegradable. You have to prove it. You cannot just say my material is biodegradable. You need to use labeling. And these are the kind of labeling you need to have. You need to have the seedling logo from the European Union, given by either the BPI, the American guys, the DIN, the German guys, and the TUV Austria, which is quite, Austria, but they are the Belgian guys. These are the schemes which are recognized by the European Union to evaluate your product, not test, evaluate your product as being BSEN 13432 compliant. And the final thing is that we give the report. Our report from Impact Solutions either can be used for your personal reasons. I mean, just to show from an independent lab that my material is biodegradable, or through the correct accreditation and certification processes, our report can go through the TUV, can go through the DAN, the BPI, or the UCAS, and give a certification that the product is indeed biodegradable. So I'll give you some examples. I mean, are our products biodegradable? So, for example, one of my customers has imported materials which are claimed to be bio-based and biodegradable. And then I've done some analysis, and the material was made from bamboo. And I said, yeah, they are bio-based, but they're not biodegradable. So, but the customer insisted that they should be biodegradable as well for being bio-based. And what happened is that no matter what test we've done, there is no biodegradability whatsoever. You can see on the graph here, we've done some testing on anaerobic digestion, and the cellulose passed the test with very easily. However, the material hasn't gone anywhere in terms of biodegrading. And the bamboo cups are just an example, a bad example, because they claim that they are bio, but they are the opposite sometimes, because they can have like melamine and other resins to hold together the wood and the lignin, which is can give you the opposite results of trying to be green. Okay, finally, some common mistakes and tips. Natural sources do not necessarily mean biodegradable. That's for a fact that I have proven with an example. So sometimes the additives that you can cause some misleading. Okay, my additives are biodegradable, but the plastic is not. So is this going to make them really biodegradable? The labeling should be clear. Really, that's one of the most important things. How you label the biodegradables are very useful in our society, and they will boost innovation, the economy, the food industry, the packaging industry, the medical industry, but they might cause the opposite effect if the consumers don't understand how to handle them. If you make a biodegradable material, you need to be clear how you're going to dispose it, how and where you're going to dispose it. If we don't succeed on that, we might then end up having, a contamination with the recycling. The plastics are very good materials, can be easily recycled. But if you mix biodegradables with plastics, then you're gonna break the chain and lose the whole point of this innovation. And then obviously toxicity testing, heavy metals content are sometimes could be too high. I mean, I've tested a material, a biodegradable bag from the Middle East. They send it to me, the government of one of the big Middle Eastern countries send me the different type of bags they had for bio that they claim to be biodegradable. And I found, for example, some occasions, they had 2,000 parts per million of lead or chromium in it. So, and these were bags that were intended to go to landfill. And that was like, it's very, very critical to be careful how we make materials biodegradable, not just by adding a lot of transition metals to make them break down easier, because these metals are going to end up contaminating the soil. All right, so what next? In Impact, we are the only lab in the UK doing this kind of tests. We are working almost 24/7 to finalize the accreditation with all these different accreditation bodies. Unfortunately, not just one, not an easy system to go with one or the other. We need to make sure we cover all the accreditation bodies. At the moment, we provide reports as an independent lab, but the next 6 months we'll be providing certificates to the customers. And we're aiming to support the industry in the UK primarily and the rest of the Europe and the world in the near future. For more information, please contact us on our website and we'll be happy to help you. So in conclusion, the ultimate goal of biodegradability is testing to ensure that the product is completely biodegradable. Okay, that's the ultimate goal of and not gonna harm the environment. And the choice of testing needs reflects the condition where you want to dispose your material tests, and clear testing, labeling, and certification of the product will enable it to end up in the right place and it will be truly biodegradable. Thank you very much for your time, and any questions I'm happy to answer. And thank you very much, my colleague, Ms. Emmeline Aves, who is a research lead at Impact Solutions, helped me with the presentation.
Excellent stuff. Thanks a lot, Dr. Mike. We've had a few questions come in, so let's go through them now. You may have touched up on this already, but I think it's important to cover in case it was missed. Will there be a separate UK regulation after Brexit in reference to EN 13432? And if so, what will or might the changes be?
A very good question. I'm not aware for any different regulations, but I am aware, that's why it's called BS. It has been adopted by the British BSI industry. So at the moment, we just go as per plan. It's not an EN standard, it's a BS-EN. So I don't see any reason why the BSI will just drop and to make their own UK regulation at the moment. But it is the whole situation is very fluid, very fluid. So the industry, and because I'm a member of the SEN committees and the ISO committees on bio, I'm aware that different standards have been produced, and let's see how the next 5 years will where that will take us. At the moment, the developers and the people who want to import biodegradable materials, they have nothing to be afraid of because the standard is adopted by the British standards industry.
Okay, cool, I see. And going back to the bioplastic testing, can you discuss the kind of materials listeners can use to test, how long it will take, along with the cost and how often it should be tested, maybe?
Yeah, okay. Basically, let's start with an example. Okay, I have a material which is made of I want to make sandwiches, packaging for sandwiches. This material is made of board, paper board, with some laminate on top, and made with a clear film, which is made of PLA. Okay, so the customer gives this material to me and asks me, Mike, I want to have a label that it's biodegradable. and I want to be clearly labeled to be for industrial composting. So what I will do is that I will take the material, I will check all the additives used, and I know that if the material is made of board, I don't need to do any biodegradation testing. Okay, it is like that's a proof that the material is biodegrading. But that I can only prove it by doing FTIR, the material characterization. And then I will focus on the film material, which is made of PLA. I will ask the customer what is the PLA type, what is the resin. Then I will check if this resin has a certification that is being biodegradable. If the resin is certified, PLA certified, then I don't need to do anything else as well. I'm going to skip the whole biodegradation testing and then move on to disintegration to test the full product, which is going to take 12 weeks, and then ecotoxicity 16 to 18 weeks in total testing. Material, testing, disintegration, ecotoxicity. If I need to test the PLA film under biodegradation, then that adds another 6 months at least of biodegradation testing. So the total testing for every analysis could be from between 3 months all the way down to 9 months of testing.
Cool. And can you identify if a material contains an oxo-degradable additive?
Yes, that's very easy. Very easy. One of the main tests you do is you check the amount of carbon is under, and you can, when you do the FTIR, you check that you can easily see the material is polyethylene or polypropylene. You're going to go back to the customer and tell them that this is not going to pass the certification for BSCN 13432 when it comes to biodegradation. So yes, it is quite easy to check that.
Cool. And I think we've just had a question come in. I'm just trying to copy and paste it into my screen so that I can see it properly. So did you work with microorganisms, and what would be the optimized conditions for studying bioplastics biodegradation and CO2 evolution, sorry?
Did we work with microorganisms?
Yes.
The direct answer is yes. This is the microorganisms are the ones which are making the whole, which we use. We take the microorganisms from different types of sources, from the marine environment, and so different microorganisms that they live in different environments. These are the stuff that we're using to do the biodegradation testing. So there are different microorganisms into the industrial composting for garden waste, different in water from wastewater treatment works, different for marine environment. And what was the second part of the question?
The second part of the question, yes, and the second part of the question was what would be the optimized conditions for studying bioplastics biodegradation and CO2 evolution?
Yeah, I mean, the optimized conditions for CO2 evolution is, I mean, that depends again. I mean, is your material water soluble? If it is water soluble, then the optimized is to use biochemical oxygen demand, BOD units, and then use a sludge from the wastewater treatment works material, which is very rich on microorganisms, and measure the evolution of CO2 indirectly by the oxygen demand. The microorganisms, the more they eat the plastic, the more oxygen they need. Okay, and that gives you indirectly, by knowing the molecular weights and the amount of carbon in the material, by knowing you calculate the conversion of the CO2. That's if the material is water soluble. A good system for non-water soluble materials is by using the respirometers, which are measuring constant flow and measuring constant CO2 evolution. So you collect some industrial compost material, you place it into reactors, and then you mix it with the plastic. the microorganisms inside the industrial compost, they start eating the plastic, and then as they do that, they give out a CO2 from the carbon which is present in the material. That CO2 is collected through infrared sensors, and then by knowing the constant flow of CO2-free air, and then measuring the output from the reactors, you can check directly now what is the CO2 into the system. So basically, you use two different types of respirometers. One is the direct identification of CO2, and the other is through BOD systems.
Okay, that answers it, yeah. And then I think there was a follow-up question in regards to those two. Would you be able to give a brief description of the commonly described biodegradation stages? So whether it's biodeterioration or biofragmentation?
It is, I think, the first that my colleague Emmeline had it on this slide, on this presentation, and I took it out at the very last moment, the stages. So she's a chemist who could be able to help you on that. So I cannot give you an answer on that. The stages, the most specific stages, that will be by my chemists.
Okay, and if that lady is happy, I can pass on her details if
Yes,
she'd
please.
like.
Yeah.
So if she can contact me, that'd be great. And also huge loads of luck to the person who asked those last couple of questions on their first year of a PhD at Queen Mary University. So good luck to you. I'm sure you'll smash it. Yeah, so I think that covers everything pretty much. Thanks a lot, Dr. Mike, and thanks to those who've listened and tuned in today. We've got another 3 webinars within the product lifecycle series coming up in the next couple of months before we move into the next phase. So please visit bpf.co.uk/lunch and learn page for more details on that. And before I sign off, have you got any final words for the listeners, Dr. Mike?
No, thank you very much for hosting us today, and thank you all the audience following this presentation. And I'm sure that the area of bio testing is going to be very popular in the next years, and we're happy to help all our customers in the UK and all over the world. Okay. Definitely.
Thank you so much. And yeah, so thanks again, and we'll see you soon on another webinar. Take care.
Thank you very much. Bye-bye.
Bye-bye.